Electrons do not orbit the nucleus like planets. They exist as quantum orbitals, which are regions where there is a high probability of finding an electron, described by a wave function. Think of an orbital like a fuzzy cloud around the nucleus where the electron is likely to be, rather than a tiny ball racing on a track. The wave function is a mathematical description that tells you how dense that cloud is in different places. And squaring the wave function gives the probability of finding the electron at a specific spot. For simple atoms, the lowest energy orbital is spherical, so the cloud is even all around the nucleus, while higher energy orbitals have shapes like dumbbells or rings, with nodes where the probability is 0. Electrons occupy these orbitals according to rules that depend on energy and spin, and when atoms bond, the orbitals can combine or shift, changing the shapes and probabilities. You cannot pinpoint an exact path for an electron because measuring its position precisely changes its motion. So quantum orbitals replace the old idea of neat circular orbits. One common mistake is picturing electrons as tiny planets traveling fixed circles, which leads to wrong expectations about position and motion. Remember, orbitals are probability clouds, not tracks. Another is thinking the wave function is a physical cloud rather than a mathematical tool for probabilities. And the practical tip is to focus on what the wave function predicts about measurements, not on imagining literal clouds. A third misconception is assuming electrons sit still inside orbitals. Instead, they are described by probabilities and can change orbitals when they absorb or emit energy. So think in terms of likely locations and transitions rather than fixed paths. For more videos and resources on how electrons occupy orbitals and how wave functions work, check out www.gumballdegree.com.